So I just thought I'd do a little bonus video as well, just because that question bored the life out of me. And for those who are curious about doing a physics degree or what it might look like, show some of the maths that is a bit more exciting and a bit more interesting that you might do in kind of any science degree, but especially if you're doing physics. So you can see a lot of this stuff some of this stuff might be familiar to you, sort of matrices and index notation. Maybe some of you have seen the partial derivative signs before. But really, it's an amazing world where maths becomes so much more than just algebra and has so much meaning. So this is electromagnetism. So maybe you've heard about electric fields, where you do them in physics, and magnetic fields. It turns out they're the same thing, and they're from the same underlying structure, and you can do all this beautiful maths, this stuff. It's called tensor analysis, and it looks really, really pretty. And all of this is working in special relativity, which is something that Einstein came up with, which tells us that space and time are also not really different things. They're manifestations of the same thing in different dimensions. So it is really, really interesting. But this is just one aspect of physics. So that's what electromagnetism formally looks like. But we could also look at quantum mechanics, for example, which is again incredibly exciting and really interesting, and pretty much every degree will have some quantum mechanics module option in it, and I recommend that you do it because it's so nice. So this is quite elementary quantum mechanics, but this is something called Dirac notation, and all it says is we have vectors, but they're part of bigger structures we call vector spaces, which have all these like rules about them. And all quantum mechanics tells us, really, apart from all this beautiful like crazy ideas you hear of like waves and as particles, are they waves or are they not, and all of these wonderful philosophy that you can do and you could think about and argue, all of that is built on a much more abstract structure, which is just mathematics, and it's just this, which is linear algebra, which is, the same underlying structure of things you've done when you've done matrices and you've done like considering lines and planes and geometry and stuff. It all comes from the same structure, but all quantum mechanics is building on the structure. So I won't try and explain what any of this means, but if this math looks exciting to you or you want to learn about it, then you should do a physics degree, and certainly it's a lot more interesting and pretty to look at than this. And there's very little of this in a physics degree, maybe in first year mechanics courses. But there's hope for us all.